Okay, so finishing number 3, we have the mu, we have our n 1055.5, etc., meters to the -1, and they told us our I was 3 amps. And when you multiply those all together, you should get 2.983 Teslas. Okay? But there's a second part to the question that says, how would this compare to an air-filled solenoid? In other words, now they want you to do B equals mu O N I, where everything's the same except you take the core out. So it'll be 4 pi times 10 to the -7 Tesla meters per amp times still the 1055.5 to the -1 and the 3 amps. Okay, so the only thing that changes is the mu becomes a mu O, and you get 3.979 to the -3 Teslas, right? So 0.003979. Look at the huge difference, right? That's a factor of almost 1,000 in the difference, which is why you put a core inside a solenoid. Okay? Number 4, an iron core solenoid. If you're going to put a core inside a solenoid, you may as well make it iron and make it good. So an iron core solenoid is 36 centimeters long, so 0.36 meters, and has 600 turns. So N is 600. The magnetic field, B, is 1.8 Teslas, is produced when 4 amps, 40 amps of current flow in the wire. What is the permeability? So this time they want you to solve for mu. So again, N is equal to capital N over L, so 600 over 0.36, so little n is equal to 1666.6 repeating meters to the -1. So then go B is equal to mu N over I, so mu is equal to B over Ni. So 1.8 Teslas over 1666.6 repeating meters to the -1, and the I is 40 amps. And you find that the permeability for iron is 2.7 times 10 to the -5 Tesla meters per amp. Okay, so that's a fair bit larger. Remember, the other was 2 pi to, or 4 pi to the -7. This is to the -5. All right, and the B part says, what would the field strength be of the same solenoid if the core was removed? So B equals mu O N I again. B is equal to 4 pi 10 to the -7 Tesla meters per amp. N was 1666.6 repeating meters to the -1, and I was 40 amps. And I think you get a B of 8.378 to the -2 Teslas. Okay? All right. I don't remember if I assigned you the transformer ones on page, whatever page the transformer ones were on. Let me find that sheet. 533. I had meant to assign, but I'm not 100% sure if I did, but I had meant to assign, I believe, 17 to 19. So if you didn't do 17 to 19, stop the video here and do 17 to 19. So number 17, because I think we did all the others. Okay, so number 17, a hydroelectric plant. Electricity is generated at P of 1,200 volts, and it's transmitted at 240,000 volts. Okay, so this one's a little bit trickier, and it's a little bit trickier because the question is which one's the primary and which one's the secondary. Well, it's generated, so that's what you're creating, and then you're sending it out at the 240,000. So the 1,200 is the primary, and the 240,000 is the secondary. So it has to put it through a transformer before you can send it out like that. Okay? And so it says, what is the ratio of the turns on the primary to the turns on the secondary? Turns on primary to turns on secondary. Their ratio will be the same as the voltage on the primary to the voltage on the secondary. So the voltage on the primary, voltage on the secondary. So some of these zeros are going to cancel. So 2 here and 2 here. And 12 goes into 24, so it's going to be 1 over 200. Or, trying to find my answers. 1 over 200, or what is that, 0.005 or something like that? 1 divided by 200. So 0.005 or 1 to 200. So it's asking for ratio, so it's okay to leave it like this. All right, that's 17A. 17B says one of the plant generators can deliver 40 amps to the primary of its transformer. What is the current in the secondary? So we know IS over IP is equal to VP over VS. So IS will equal IP VP over VS. So it says the current in the primary is 40 amps and times 1200 over 24, 2, 4, and 4 zeros. Okay, so 3 zeros cancel. A 12 cancels, there's a 2, so you have 4 over 20. 1 over 5, so I think this should be 0.2 amps. Okay? That's 17B. Oops, at a page. 18. A hairdryer uses 10 amps at 120 volts. 18. So we have I is 10 amps, and I'm not putting V or S, V or P or S here because we need to figure that out. And then we have a V of 120 volts. It's used with a transformer in England where the voltage there is 240 volts. What should be the ratio of the turns? So a hairdryer uses 10 amps at 120 volts, but England supplies 240. So the 240 is the primary, and the 120 is the secondary, okay, which means the 10 amps, what the hairdryer needs, is the secondary. What should be the ratio of turns of the transformer? So NP over NS should be equal to VP over VS. So 240 over 120, the ratio is going to be 2 to 1. Okay, that's part A. Part B wants to know what current will it draw from the 240 line, in other words, what's IP. So IP over IS equals VS over VP. So IP is equal to IS VS over VP. So IP is equal to S is 10 amps times 120 volts over 240 volts. IP equals, this is 1 over 2, should be 5 amps. Okay, so 18A and B. And since I have no more time left, but if you can do numbers 19, 20, and 21, and I will do a video of that for tomorrow, so feel free to keep going, but there'll be another one here